Hi, RC fans. This is another time engineer. You are welcome. Unfortunately, I've been out of the internet for a long time. But the past weeks, I was doing some projects with my students. We were moving for exhibitions up and down. It has been a whole hectic lot of time. But now we're back in business, and I have a surprise for you. So let's get into it. All right, so there you have it. This is GHF Josephine. Now this is a UCAV for unmanned combat area vehicle. So over the past years and months, we're developing civilian aircraft or civilian drones. This time around, we want this to be an military concept. So this will be in the likes of the Predator, Anchor, or those high intelligence. We have the MALE, that is medium altitude, long endurance drones. This one is supposed to replicate or mimic the missions of those, high-end technologies. Of course, we can start with something. So this could be used for ISR. ISR, intelligence, surveillance, reconnaissance. And then, just as you can see, for the first time, we are trying to develop a strike aircraft. So it has a six weapons base for dropping gravity weapons, and we will also try to simulate weapons dropping. So let's get into it. The whole aircraft from wing to wing, the wingspan is 6 meters. So it's sizable, 6 meters wing to wing. Then the length is about 5.2 meters. The aspect ratio on the wings is around 11. The chord is around 80 centimeters, so it's a pretty high aspect. Then the height from, of course, ground to the horizontal tail is around 1.8 meters. I hope to increase that to about 2. I realize that the vertical stab is a bit short, so I'll add some 20 centimeters to raise the height. And so that is that. As it stands now, it weighs around 38 kilos. The actual framework I did using half-inch plywood box, and so that has been the structural framework and very strong, very robust. Then I use the polyurethane styrofoam to do the covering, of course, glue it, and in the end, I hope to reinforce, especially the nose section, with some fiberglass, epoxy, resin, and glue hardener to strengthen the structure. So that is it. Let's get into it. With the nose gear, I use this is 7-inch PU ties, so very strong. And the strut, of course, is metallic, so I had to weld both for the nose and then the landing gear. Then the steering system I'm using this 20 kilogram digital servo. You realize that's a very heavy duty servo, and that will be used for the steering system. So that is that. The whole gear can be screwed and unscrewed. There are four sections holding this, so it can be unscrewed for transportation. The same applies for the main gears. The tires are 8.5 inch at about 19 centimeters in diameter, and two of them also very strong. The landing gear, the struts are also welded metallic. The two of them weigh about 5 kilos, so pretty light for that. Okay. Then for the motors, I already had these four of them, very heavy duty motors. So these are 50, 65, 435 kV motors, 50 by 65 centimeters, 435 kV motors. The propeller, this carbon fiber, is 18 by 6. I think 18 by 65, 6.5 inches, and very heavy duty. The thrust from each of them at 5S is around 5 kilos. So 5 kilos times 4, I'm getting 20 kilos of thrust. The aircraft weighs about 40 kilos. And so I have enough thrust to get that one going. Then let's look at the wing structure itself. So two main spars. The main spar, that is the front spar, is located just around the 25% chord line. So it runs through or to the edge. Then the rear spar is also here, about 25% from the trailing edge. That also runs through there. They have five major reps, very strong, and the whole thing, I think I put a weight of around 30 kilos, 30 kilos on it, and was able to take it. Unfortunately, I've lost my files. My phone has some problem. I'm trying to recover those files to get those photos and videos to add them. So the raw framework of the wing could take about 30 or more kilos of stress or force. And that is fine. Then on the weapon system side, we're having three weapon stations or three hard points. So three here, that means six. Then we'll look at that later. Then for the wing section, yeah, before that, so the motors have that one at maximum power at full throttle. They are taking around 45 amps of power, and I have four of these 80 amp ESCs. Two are here, two are on this Embraer 145. I hope to get. I have ordered two, so I'll be having six of them. So 480 amps for each of them. Very, very enough, and that will be it. Then for the battery system, I have two of these. This is 12,000 milliamp hour, 18.5 volts. So this is 5S, heavy duty. One is about 1.8 kilos. So two of them, one for each two, and that should be enough to power them that way. Then on the ring tips too, we had this small ring tips, very nice aerodynamic one for it. So this is the ring fence, vertical here. But then here, of course, there's high pressure air trying to come here. And this is a fence that will block that leakage of air. It is very smooth aerodynamic shape, looking very nice. I have marked the control surfaces, ailerons here, flaps there, but I've not cut them yet. But of course, just after the vacation, I'll do that and that'll be done. One thing I spent quite some time working on was the wing box, how to attach the main wing to the fuselage section. Originally, I was trying to see if I could use bolt and nuts, just as I've used for the landing gear. Then I realized that the stresses would be too much for it, it couldn't handle it. And so I went in rather for this two strong wood, and this hard wood. So two of them. Once again, this is also removable, so we can remove this one. So all the parts could come, the aircraft to come apart. Left wing you can remove it, right wing, remove it, and then it comes here too. For the nose, sorry, the tail section, the whole empennage here is also hooked to this. So there are five of these bolts and nuts. This is 13 mm. Five of these holding all these things together, and then the tail servos, rather elevator, come in here. We run them through the fuselage. So for easy of transportation, this goes off, and all the other sections also goes off. For the tail, we have this section. I'm yet to fix the radar and then the elevator. They are both made here, but then this is the actual structure. So the vertical staff and the horizontal staff are also connected with these two. So for ease of transportation, we can remove this one. Very simple. This one can also go very simple. And so this, the whole of this is about 2 meters across. That would be nice for transportation. So that's that. Yeah. Okay. And very tough, very nice, everything. It's in place. So the other bit is for the weapons system. Uh, in this project, I hope to simulate the weapons drop. This wouldn't be the final design, but I've already worked on that. So this will be most likely a gravity assist bomb. So this will be hung to this using some servo locking mechanism. So there'll be two servos that will hook together before takeoff. Then during altitude launch, release the mechanism. I'm planning to attach all of that to one channel on the transmitter, and then when it releases, all this will drop. The final product will be packed with powder, some very fine powder. So when it releases, I also create a hole, and hopefully, I will drop in such a way that it will land facing down. Maybe I'll put some weight here to drag it down. As it drags down, the powder will be pushed outside, then it will form a smoke on a line. So that will be like a missile launch to simulate that. And the material itself will be also soft enough so that by the time it hits the ground, it will break apart. The rest of the powder will explode, and it will simulate that bomb drops. So we have 6 of those things there. Then the mechanism has already been designed, and I'm almost done with it. So yes, that was it. This is for GHF Josephine. It's a very interesting project. I've been working on it for the past month or so, and it is time for vacation where I am. So within about 2 3 weeks, we'll be back in school, and then back in the lab, we'll be working on all these things. This will be in partnership with the Ghana Air Force. We've already um, notified them that we will need their test site. We have an airfield, the test site for it, the AFUA airfield around Tana in Ghana. So when it's time, we will send a notification. Then we'll go and have a test flight and the systems, all these things there. So it's been nice. If you're interested in helping us, and we also like you to help us, please, I will leave some links and comments, contacts, email information in the links below. Please be sure, don't hesitate to come to us and help us finish this project. It's a win for all of us, and I'll see you next time. So stay tuned for the project.